LWO1 WeatherNet. Liftoff conditions looking pretty good.
ESTS is ready for launch.
Ignition. Liftoff.
Falcon 9 has cleared the tower.
Ten, 9, 8,
Side booster ignition.
6, 5, 4, 3, 2, 1.
Good evening. It's Tuesday, November 23rd, and on your screen is a live view of Falcon 9 as it awaits its 10:21 p.m. Pacific time launch from Space Launch Complex 4 East at Vandenberg Space Force Base. My name is Jesse Anderson. I'm a production and engineering manager on Falcon 9 here at SpaceX. Welcome to our webcast coverage for the Double Asteroid Redirection Test, or DART mission, managed by NASA's Launch Services Program. If you ever saw the movie Armageddon or played asteroids as a kid, this mission is for you. DART is SpaceX's first interplanetary launch for NASA and the first planetary defense test to see if humanity can change the motion of an asteroid in space or stop it altogether. As part of NASA's larger planetary defense strategy, the DART mission will prove that a spacecraft can autonomously navigate to a target asteroid and intentionally collide with it, a method of asteroid deflection known as kinetic impact. The target asteroid, which poses no threat to Earth, is the asteroid moonlet Dimorphos, which orbits a larger asteroid named Didymos. If all goes as planned, DART will direct itself to impact Dimorphos at roughly 15,000 miles per hour or 4 miles per second, which is 6 kilometers per second, just under a year from now, somewhere between September 26th and October 1st of 2022. Scientists will use telescopic observations of the asteroids, images taken by an onboard camera, images of the DART impact event collected by an Italian space agency CubeSat, and data collected later by the European Space Agency's Hera mission to build a more accurate model and better prepare us to successfully defend the planet should a future asteroid impact threat ever be discovered. The DART mission is an awesome example of science fiction becoming reality, and the SpaceX team couldn't be more excited to be launching this payload to space. We will learn more about the DART mission later on in the broadcast, but first, let's take a closer look at the vehicle on your screen. Now, as many of you may know, on your screen is a live view of our Falcon 9 launch vehicle. Our two-stage liquid-fueled launch vehicle is in position at Space Launch Complex 4 East at Vandenberg Space Force Base. Today marks the 26th mission for SpaceX this year and 128th flight of a Falcon 9 vehicle overall. This is SpaceX's first flight-proven launch for NASA's Launch Services Program. This first-stage booster supported Sentinel-6A around the same time last November and took its second flight on a Starlink mission in May of this year. Now, if you're new to our webcast or unfamiliar with Falcon 9, what you see at the bottom two-thirds of the vehicle are SIP markings from its previous two flights. These markings are located on what we call the first stage, or the booster, and the first stage's primary role is to accelerate the vehicle all the way to the edge of space with the help of 9 Merlin engines. It will then drop off the second stage carrying today's payload, which is NASA's DART, or Double Asteroid Redirection Test spacecraft. Now, following separation from the second stage, the first stage will make its way back to Earth for the third time, where we will then attempt to recover it on our autonomous drone ship, Of Course I Still Love You, and that is a live view of that drone ship right there on your screen. Now, if you turn your attention to the section above the first stage and the black carbon fiber inner stage, you'll see Falcon 9's second stage. About 2.5 minutes into flight, the first and second stage will separate, and the second stage will ignite its single Merlin vacuum engine to carry the DART spacecraft to an interplanetary trajectory, as I mentioned earlier in the webcast. Separation from the second stage will occur, and then the spacecraft will perform burns as it begins its journey in space. Now, finally, above this stage, placed at the very top of the vehicle, you'll see the nose cone structure, and that is called a fairing. Inside of that structure is the DART spacecraft. The two fairing halves are safely encapsulating the spacecraft to protect it from aerodynamic heating, loads, and contamination during ascent. The fairing halves we are using today are brand new, and we plan to recover them on our recovery ship, NRC Quest. Now, once the vehicle reaches the vacuum of space, we will jettison the fairing halves as the second stage continues on its journey to orbit.
Good evening from Hawthorne, California. I'm John Isbrucker, the Falcon Principal Integration Engineer. Now, the launch vehicle and spacecraft are in good health and ready for launch as we approach T-minus 13 minutes, 30 seconds to liftoff. The Falcon 9 team reported on console at T-minus 2 hours, 15 minutes. We received the final countdown briefing from the SpaceX launch director, and we began the final checks of the launch vehicle and the ground systems. Final checkout of the flight termination system was performed at T-minus 1 hour, 45 minutes. Now, most recently, we completed the poll to proceed with propellant load and launch. Propellant loading is ongoing. We started it on time at T-minus 35 minutes. Now, Falcon 9 is a bipropellant vehicle, meaning it uses two propellants, a fuel and an oxidizer. For Falcon 9, our fuel is a refined form of kerosene known as RP1. Now, to burn the fuel, we need a source of oxygen, which we call the oxidizer. Most burning on Earth uses oxygen, which makes up about 21% of the air you breathe. However, in space, there is no atmosphere to provide oxygen or other oxygen-bearing molecules, so rockets need to carry their own. Falcon 9's oxidizer is super chilled liquid oxygen called densified LOX. The liquid oxygen is chilled well below its boiling point to increase its density, and that allows us to load more into the first and second stage LOX tanks. Now, currently, fuel loading is complete on the second stage. We're continuing fuel loading on the first stage up until T-minus 6 minutes. Liquid oxygen is loading on the first and second stages right now. Now, in addition to its propellants, Falcon 9 also needs an ignition source to start burning the fuel and oxidizer. And for that, we use the chemical T-tub, which stands for triethyl aluminum and triethyl borane. We ignite the engines by first flowing some liquid oxygen and T-tub into the gas generator and the main combustion chambers. The T-tub burns in the presence of oxygen. So once we get that ignition, then we can introduce the RP1 kerosene fuel, and the Merlin engine goes to full power for liftoff. Now at liftoff, Falcon 9's two stages combine to hold over 1.1 million pounds propellant. And we'll burn through most of that over the 8.5 minutes it takes to land the first stage and get the second stage into its initial orbit. Now, once our Merlin engines begin to burn the RP1 kerosene fuel and the liquid oxygen, you're going to see the rocket essentially throwing the combustion exhaust out of the engine nozzles in one direction, resulting in a push on the rocket in the opposite direction. And this is the great example of Newton's third law of motion. For every action, there is an equal and opposite reaction. Now, we started the day with pretty good weather forecast, and the good news right now is weather officers giving us a 0% probability of violating launch weather requirements. The ground level winds are good, the upper altitude winds are good, and we don't expect to have any weather holds for launch. The weather conditions also look good for booster landing on our drone ship and for fairing recovery in the Pacific Ocean. So with that, the launch vehicle, the spacecraft, the weather, and the range are all good to go for a 10:21 p.m. Pacific time liftoff from Space Launch Complex 4 East.
Liftoff of Falcon 9 will kick off a roughly 11-month journey for the DART payload. The DART spacecraft will separate right around 56 minutes into flight, and from there it will spend the next 11 months cruising to its intended destination, intercepting the binary asteroid system between late September and early October of 2022. DART's target asteroid is the size of 2 football fields. Impact will occur when the distance between Earth and the asteroids is near its minimum, within 6.8 million miles or 11 million kilometers of Earth. This will enable scientists to observe and measure the change in momentum of the Dimorphos asteroid. And it's worth noting that Dimorphos is not a threat to Earth. Therefore, it's a perfect testing ground to see if intentionally crashing a spacecraft into an asteroid is an effective way to change its course should an Earth-threatening asteroid be discovered in the future.
Now, the DART demonstration has been carefully designed with 4 key objectives. The first objective is to demonstrate a kinetic impact with Dimorphos, the smaller of the 2 asteroids. DART will hit the asteroid nearly head-on delivering enough energy to leave an impact crater, but not enough to destroy the asteroid, eject it from its orbit around that larger asteroid, or noticeably change the pair's orbit about the sun. Now, the second objective is to change the binary orbital period of Dimorphos. Now, the orbital period is the time it takes the smaller asteroid to circle the larger asteroid you can see here in the graphic. Currently, Dimorphos is in that original orbit. Scientists estimate the collision will shorten the smaller asteroid's orbital period by several minutes, placing it into that new blue orbit. Now, the third objective is to use ground-based telescope observations to measure the orbital period change before and after the impact. Telescopic observations in the weeks after impact will confirm that DART changed that orbital period of Dimorphos, and it'll reveal by how much. And then finally, the fourth objective is to measure the effects of the impact and the efficiency of that deflection. Now, choosing this binary asteroid target for the demonstration takes advantage of the fact that changes in that smaller asteroid's orbit around its larger partner can be more easily measured than the changes in a single asteroid's orbit around the sun.
To ensure the best possible data capture, the DART mission is taking along some pretty cool technologies to help capture this demonstration test. On board the spacecraft is the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, also known as DRACO. Now, this is not to be confused with the Draco thrusters on SpaceX's Dragon spacecraft. DART's DRACO will provide real-time streaming images of the asteroid as it approaches impact. In addition to the onboard camera, the team is also flying a CubeSat from the Italian space agency known as LICIACube, which stands for Light Italian CubeSat for Imaging of Asteroids. This cube will be deployed from the DART spacecraft 10 days prior to impact with the asteroid. LICIACube will use its onboard propulsion system to alter its trajectory, offsetting so that it flies past Dimorphos approximately 3 minutes after the DART impact to capture the effects of the impact. Now, it's pretty incredible to think about what a mission like this could mean for the future of planetary defense. Now let's take a closer look at what the NASA team is hoping to achieve with the Double Asteroid Redirection Test mission.
In case there was an asteroid coming towards Earth and you're there, you can actually stop it. I mean, that's kind of fantastic.
NASA is crashing a spacecraft into an asteroid.
What? You think science fiction, but this is real.
Never in my life would I have thought I would take a couple $100 million spacecraft and crash it into an asteroid. My name is Michelle Chen.
I'm Lena Adams.
My name is Kelly Fast.
I'm Andy Rifkin.
I'm Justina Sorovitz, and I help tell the story of the DART mission.
I'm a planetary defender.
And I study how the orbits of asteroids change after we hit them with spacecraft.
My job was primarily to make sure all the systems on the spacecraft work together.
The DART mission is NASA's first test of a planetary defense technique called kinetic impactor.
DART is the Double Asteroid Redirection Test.
It's just a spacecraft that is going to go and smack an asteroid.
The moonlit Dimorphos, which orbits the asteroid Didymos.
And see if we can change its trajectory just a little bit.
In order to show that we can deflect incoming asteroids if we need to.
DART will only be changing the period of the orbit of Dimorphos by a tiny amount.
But in space, just a little bit is just enough to make an asteroid actually miss us.
In the event that an asteroid is discovered well ahead of time before it might impact Earth.
Behind me, you see the spacecraft.
It's really cool to see it coming together in real life.
It is fantastic to see it in real life.
To see it turn from ideas into real pieces that are going to go into space.
The solar arrays will actually roll out to 28 feet in length.
Once the solar arrays are deployed, it's going to be the size of a school bus. As the solar array opens out, it's going to swing out in this direction. The asteroid's only 2 football fields in size.
We're flying at over 6 kilometers a second.
30 days out, we see 1 pixel on our field of view.
You can see Didymos and Dimorphos as 1 point of light.
About 4 hours out, our spacecraft becomes autonomous.
And then that's where everything gets really exciting.
You actually are seeing impact.
We're super excited and nervous as well.
I feel really honored and humbled to be working in an area of science that has such a broader impact, figuratively and literally.
No DART! The dinosaurs are made completely extinct by an asteroid impact so many years ago. Here we are, we can actually do something about it. I think this is just wonderful.
It's currently T-minus 4 minutes and counting. Everything continues to be go for launch. Spacecraft is transferred to internal power. Now on your screen, you can see the large structure next to the Falcon 9. That's the strong back. Currently, the clamp arms have opened up, and you can see that the strong back has begun to retract away from the rocket. It's moving all the way back to a launch position about 77 degrees upright. Now this is different from Falcon East Coast launches, where we move the strong back only 2 degrees, and then we retract it the rest of the way at liftoff. At Slick 4, once we get it back into position here in about another 40 seconds or so, we won't have to move it farther away at liftoff. Also, while we were watching the video, we have completed the fuel load on the first stage on time as expected, and we've begun chilling of the Merlin engines. Coming up on T-minus 3 minutes, everything continues to be go.
Stage 1 LOX load complete.
And we just heard that call out, LOX load complete. That is the first stage LOX loading being completed. Second stage will complete around T-minus 2 minutes. And Falcon 9 and DART teams continue to track no issues for launch. Weather is still looking great, as John mentioned. The range is ready to support, and SpaceX team is monitoring the completion of that second stage. Coming up next, around T-minus 2 minutes, we should hear LOX loading completing for that stage. Now, as a reminder, we do have, if we do have a hold on today's launch for any reason, we do have a backup opportunity tomorrow with a liftoff time of 10:20 p.m. Pacific time, just a minute earlier than tonight.
Coming up on T-minus 2 minutes, waiting for the call out that LOX load is in closeout.
Stage 2 LOX load complete.
There we go. Stage 2 LOX load is complete. This completes loading of the over 1.1 million pounds propellants on the Falcon 9. All systems remain go for launch. Now the SpaceX ground computers are now draining propellant out of the lines that go up the strong back to the second stage, and that creates the white cloud that you see around the strong back. Pressure from the ultra-cold liquid oxygen line is being vented, and that causes moisture in the California night air to condense. Next event will be the startup call out at T-minus 1 minute. The first second stage computers on Falcon 9 will execute programs to prepare the rocket for flight, leading to ignition of the Merlin engines at T-minus 2 seconds and liftoff at T0.
Falcon 9's in startup.
There's that call out. Falcon 9 computers are now running the final sequence for launch. First and second stage tanks are beginning to final pressurize for launch.